All right, everyone, week 4. I know we're in week 3, so hopefully you're getting used to the way we lecture, right? So let's show the students and say hi to all the online folks. Hello, welcome in. Okay, so hopefully you know this is computer concepts. If not, I'm worried about you, okay? Thank you for laughing. I always appreciate that. All right, so a few class topics. So in your notes, class topics. I want to start with this. And the reason I'm starting with this is that I did this in the second video for this class. But not everyone got it, and I want you to, so in your notes, all you have to say is security audit in Google Docs, and here's what I want you to do. So in your doc, and you should have created 2 directories, right? Shared with Rio and shared with everyone. In the shared with everyone, and here's what happens. Some people double click into a directory and then start sharing the items in the directory. And that's not what I want. What I want is for you to change the permissions or the sharing at the folder level, because then anything that you put in the folder inherits that. So what I want you to do on your own time, before you submit classwork, and for the online students, I want you to make sure you've set it up like I'm about to show you. So on the shared with everyone, you click once, you come over to the person icon, you bring it up, it should have get shareable link as green. If that's the case, that folder is set up correctly. I do not need to be listed on that folder because that is anybody that has a link to with this, anyone that clicks on a link that is in this folder, it is visible. Now, how is the shared with Rio different? Only you and I see it. Now, because it's my own directory, we won't see it, but we'll talk about what it should look like. When you click on the shared with Rio, only I should be listed and I should have edit ability. Okay? So in your notes, I want to make sure you go and check that to make sure you've done that correctly, because I'm still getting individuals emailing me. Like if I see you're sharing a doc with me, it's not right. Okay? And really it's really about learning about this concept, about sharing, and long-term wise, once you set it up right, and I've said this before, it's all good from here on out. Okay? Any questions about that? So again, make sure you're clicking at the folder level, clicking on the person, and you should be good to go. Okay. All right, next item. Oh, thought I had it up. Okay, there we go. The other thing I want to institute now is some a little bit more clarity on the requirements for classwork. So in the shared with Rio, in classwork, okay, I want you to start doing this. Each week, I want you to use a title format. And what this means is when you select the week, you come in here and you select title. So each week will have a title format, and then within the week, you will have heading 1s as major topics. And you might have headings 2s, but definitely have, and I generally tell you, although you may see me stop doing this, how many headings you should have for that classwork. Okay? So I want, for each week, what format do you use? Title. And for each major topic, heading 1, which, by the way, you're going to learn, if you haven't already started on the Code Academy about this anyway. Okay? All right, so that is the formatting I want on classwork from here on out. All right? So let's talk just a minute and do both the screen and me. Good. So in this case, I also want to give you the heads up, right? That you've been doing, and you're some of you have already started on the chapter 2 for Word for my IT lab. But remember, this is all really heading to the most important part of the My IT lab, which is actually the lab test. Okay? So if we looked in Canvas, we could look at the calendar. And in the calendar, we would see, after we finish Word chapter 1, 2, 3, and 4, we have our first lab test. Okay? So I'm just going to roll forward a little bit in the calendar here into February, I think. Right? So here in February 22nd is your first lab test. So in your notes, just put the lab test. And let me show you where you find them and generally how they work. So in the My IT lab, and now you can switch back. Good job. So where you will find them is under course materials, and they haven't been made available really until like today. So you will see them pretty much when you get in the next time. You scroll to the bottom, you find exams, okay? And under exams, you'll find Office Lab Test. And under Office Lab Test, you will see the 3 lab tests that you will have for this class. Now, why this is important? Each lab test is worth 5% of your grade. So this is why I've been saying, for those of you paying attention, which many of you have been doing a great job with this, when you're doing the My IT Lab stuff, you're really helping yourself the most if you open Word in this case and actually do the work that they're showing you how to do, okay? So in addition to the assessments, actually open up Microsoft Word and do it. Now, also to do these lab tests, you actually have to have Microsoft Word. So if you're not doing it in lab, you have to have it, but I've talked about several times, where do you get it? Yeah, in your campus email, it's free. I love the big F word, right? It's free, which it hasn't been until the last couple of years. So let's just click into here. Yeah, Sarah.
When we do the trainings and we get the summary,
Yeah.
the submission summaries,
Uh-huh.
are we able to use those?
Yeah.
For the lab test?
Yeah, absolutely. Yeah, so Sarah's asking, if you didn't hear it online, is, by the way, and bring it back to me, FYI, when you do, for those of you that don't know, but I showed this, when you do the trainings, after you submit them, and even if you just went in and submitted it without doing anything, when you do click on it and view submission, you see all the detail of what each step needs to accomplish. So that's good to know that you can see that. And Sarah's asking, can I use that to do the lab test? And absolutely, right? Do whatever it is you can do to do well. So let me just show you this. Does that answer it? So on the Word lab test, when I click on it, by the way, anybody know why it didn't open? Yeah, nice pop-up blocker. Okay, so I'm going to go allow this. And for me, I travel around a lot of different computers, so I often have to do this. So if you're working on a new computer and that happens, it's like, oh, that's why. It should, but on these computers it forgets every time, right? So there's 3 steps. So in your notes, there's 3 steps to a lab test. You download the files, you work on the assignment, and then you upload the file. So let's just download it. So when you download it, this is going to download either, there's 2 files in here. Both of them are docx. Anybody know what a docx extension on a file name means? The most current version of Word. Used to be a doc, now it's a docx. But you can either download them individually, or you can just grab all of them and say download all those that zip file. Have you heard of a zip file? Yeah, so a zip file is one file that contains multiple files generally and is compressed. So now what I'm going to do is I'm going to go ahead and click on that, and then I'm going to do extract, because right now what I'm looking at, and this is generally true on Mac and PC, you're looking at what's inside of the zip file. So what you want to do is extract all these files, and this is telling you where it's going to put it. So it's putting it in this download directory, and I'll hit extract. So make sure you do not work on them when they're setting in the zip. Make sure you do what? Extract them. So you have 2 files in the Word example. I think on the Excel you have a few more, and on the Access maybe 1 or 2. But you have instructions. So the instruction is just that. You have each step you need to do, and it's 18 steps, and you can see points. But again, what you want to keep in mind is the overall percentage of this item is how much? 5%. Very nice. Hopefully that stuck in your brain, right? So here we go. We go through all the steps, and what you do is here's the file you work on. Now, let me be clear. My IT Lab, once you download that file, that is uniquely identified to you. And if you, and I don't think anyone in here or anyone online would think about it, but if you did get a file from someone else, it will be flagged for integrity violation, okay? Basically, that means you cheated, okay? So don't do it. Don't get a file from somebody else. And here's the other thing. Once you start working on this file, take it with you. What would be an easy way to take files with you these days?
Google Docs.
Very good. So Google Docs totally makes sense given that I've pushed it so hard, right? But here's what I want you to know. If you upload a docx into Google Drive, make sure you do not convert it into the Google format. because that will throw security violation. So if you upload it, just make sure you keep it in the native file format. What's another way you all take files around with you? Yeah, how many of you use flash drives? Do you? Yeah? Okay. So that's a great way too, but however you do it, once you start working on the file, you can take it with you, but if you download it again, you're going to have to start over, so don't do it that way. So, good so far? So I downloaded, I unzipped, and I looked at the instructions. Here's the file. So when I'm done, what I would do, and let me go back here, after I work on it, then I would upload the completed file. So in this case, the only file that you have to upload is the file that has all the work done to it. Okay? So I believe I've set this, and if not, I will, to give you 3 attempts, which, by the way, on the assessments, you have 3 attempts, meaning you can try it 3 times. So you can try it 1 time, upload it, see what you got wrong. You don't have to start over, just tweak the pieces that you missed and upload it again. So in your notes, how many times can you resubmit? 3. Okay, cool. So by the way, right here at the last step, you have to, once you upload it, you have to finish for grading, and that will pretty much immediately tell you what your scores are. So it's graded by my IT lab, not by me. All right, any questions here? I'm going to go ahead and leave this, which is probably not the best way of showing it, but I did. Okay, so that is the lab test. And by the way, make sure, I've been saying it for a while now, but let's all be clear, because I actually went out and checked the numbers. After February 5th, which is when? Next Friday. You can no longer get My IT Lab. So if you do not have My IT Lab, which is a required part of this course, after next week, you cannot do it. And again, I went and looked at my enrollment versus the people that are in my IT lab, and some of you are not there in my overall, all of my classes. This is not a decision I make. This is a decision that's made for us. I don't agree with it, but that's okay. Sometimes we have to do things we don't agree with. You ever felt that way? It's like, no, why don't we give you the whole semester? But okay, all right. Okay. So here's the other thing. On the hands-on, which I already have week 4 up there, and I will probably put up week 5, because for the next, I think, 4 weeks, maybe so, we're going to be doing the Code Academy. It's been really fun for me to watch your feedback on Code Academy. It's like you either didn't like it or you loved it. That's kind of the love-hate relationship with coding, right? But I will tell you, some of you do not still realize, matter of fact, let's see, how many of you know, and let's show them, that I give print screens for help? Okay, good. If you don't, let me show you, because, don't work harder, work smarter. So I started it on the very first one. I'm in January, so our very first one is where, right here? Yeah, and actually it's on 4 too, so I can just look here. So here is a print screen of each step, okay? So if you're struggling with code, which, by the way, some people don't even want to look at it because they want to see if they can do it without it, which I admire, right? Totally. But if you're struggling, go look at the code. Look at the code so you know what it's supposed to look like. And again, coding is an exercise, put this in your notes, in precision. It's an exercise in precision. Precision, because you miss one space, one character, and it will not work, okay? This is part of why it's also good for your focus. And again, I was listening to the news a couple mornings ago, and they were again talking about how important it is to teach coding. This is like the 2nd time in the week I've heard on mass media. They're starting to get this, right? That we need to be teaching this stuff. Okay, I think that was all I had for that. Let's see. Oh yeah, so on Friday, this is on, by the way, who knows how to find my office hours? Where do you go? Syllabus, right? And if you haven't gotten used to this, on the syllabus on our course, I provide the syllabus 2 ways. Anybody know the 2 ways I provide it? I provide it embedded, so it's a Google Doc, but I provide it embedded, in which just means below, or you can look at the whole thing. But either way, if you scroll through down here, you will see my calendar. So my Friday office hour is a virtual office hour. So I wake up in the morning, do my normal grading. So I'm not here on campus, but here's what I want you to know. If you want to meet with me on Friday, just give me at least a 24 hours heads up. And if I don't have anything where I can't come, I will be happy to meet you on Friday. Okay? So, but in general, my Friday office hour is a virtual office hour. Okay. Questions about that? Cool. So now let's get into the topic for the day. Welcome to the revolution, my friends. What revolution do you think I'm talking about? Digital, good. What else? What? Technological, very good guesses. Not right yet. So in the first, and last week, you guys, if you haven't done it already, you've watched the Humanity from Space. And really, I do this to kind of set the context for what we're learning, the importance and the impacts of technology. Here's kind of a fun image that I think helps talk about this. Anybody seen this image before? How many seen it? Yeah. So, you know, evolution of man. This is not debating evolution. Okay, I'm just going to tell you, although it's real, and you know, if you don't believe it, okay. But so in this case, man has evolved over the years, and part of the evolution has been the tools, right? Humans have evolved over the years because of the tools that we've used, right? We've come out of the caves, we started plowing, we used printing presses, we used steam engines, we used, the Industrial Revolution ultimately to get to the computer, right? And there's some really interesting points here, but I've been thinking and reflecting on this, and I came up with, you may not find it funny, but I did. I thought about this, like, think about these folks that were living off the land. Really, what was the big tool they used? The sun, absolutely. They were very much in touch with their land and their world, right? In a way that I think we have become very much disconnected, just the nature of our evolution. So when you think about this, then think about current, like our current world. And I thought about, like, who would I want to, in my dreams, to see have a conversation? Like the plow, the farmer, and, drum roll, the Kardashians. Right? So why would the Kardashians be a reflection of our current revolution? What have the Kardashians done? By the way, of their own account, they say they have no talent. Well, they don't say it like that, but okay. But if they don't have any talent, how are they so freaking popular? By the way, I don't watch them, but somebody does, because these people are way popular. And by the way, they were already rich before they got popular, right? What is it that they did using the revolution that we're in? Social media, which is really just, and this is the revolution we're in, and put it in your notes, an information revolution. So the Kardashians really learned how. I was flipping through something the other day, and I saw the mother talking about it was really Kim Kardashian that got started. Everyone started on social media. Before Kim did it, nobody knew how to do it. And Kim taught everyone, right? And by the way, what's the other thing that the Kardashians have done? They've created an app. Yeah, their app is really popular. I don't even know what it does, but I hear I would never download it, but it's really popular. Now, they're probably not the best example. So I thought, well, let me think about, like, again, the conversation, and it would be just fun to be a fly on the wall to hear these folks and these folks talk. I don't even think they could communicate, honestly. Right? I don't even think they could have a common understanding. So, but it'd still be fun. But I thought, here's the other one, right? So how about the ALS Ice Bucket Challenge? That, I think, is a good reflection as well, but just a reflection of our current state of information revolution. I mean, my God, do you realize how much money was raised for ALS? And how much awareness was made for their cause by this? Huge. They used the information revolution to change a lot of the way people saw how many of you watched Ice Bucket Challenges? Most of us, right? We did. Anybody do one? Did you? Nice. Every day's nice. Okay. So here's my point. Boom, boom. The point is that we are living in the information revolution, and what's powering this revolution is by no doubt the computer. right? So this chart, so make sure you have this in your notes. What revolution are we in? Information, when what's powering it? Computers, technology, right? So this chart is really kind of interesting, and just show the chart for a minute so we can chat about it. So this chart is kind of a classic chart in computer we talk about, in computers technology. So over here is the cost per calculations per second per thousands of dollars. So how much it costs basically to compute. And over here is time, okay? And over here, this one right here, is the intelligence of computers. So what we're looking at is basically, by the way, it even says it up here, this type of chart is a exponential chart. So at some point, because it just keeps growing and growing, the capability to do computation, right? We are in, and by the way, we are right here, right? We're basically right here. So and we're on track. Our computer intelligence is at a mouse's brain. But yeah, right? I mean, think about the kind of stuff that computers can do today. I mean, is there anything you've seen recently that you go, wow, that's cool? Anything? Anything you want to say? Because I know I got examples all day. Anybody got one they've seen lately that they went, wow, computers can do that?
I just have my phone. I just realized if you hold the back button, there's two apps at the same time.
Yeah.
And I've had my phone for like 3 years.
Right.
So yeah.
So the smartphone is really smart, right? I mean, it's amazing. You can talk to it, which, by the way, how many of you know that smartphone is tracking you, though? Okay. So if you don't know that, I mean, part of the reason it's so smart is it knows pretty much everything you do, right? Last night, I was at a party, and I was at a dinner party for a friend, and I took a picture of her, and boom, I got a message I had never seen before. And it said, hey, you want to send this person this picture? And so what happened was Facebook Messenger did a face recognition, found the person, knew who it was, asked me if I wanted to send it to them. I had this moment of, seriously? Wow, right? The other one I've had recently is I was walking somewhere and my phone popped up and said, hey, there's something going on over here. You want to go? I'm like, maybe? I don't know. Maybe? The other one is, how about the Amazon Echo? Have you heard about the Echo? Right? You just talk to it. It talks back. Siri. I mean, our phones talk, right? I mean, this is just the beginning. We are here, my friends. What's it going to look like as we get further? Wow. Whoa, right? It's going to be fun to watch if you ask me. But also, here's the thing, and I'll come to you next. Here's the thing. All of our movies depict this as really a bad thing, don't they? I mean, really, think about it. Terminator, iRobot, Minority Report. I mean, they depict the future in really not a good way. Yeah, comment. Eagle Eye, yeah, Eagle Eye, right? Another, again, bad things are going to happen in the future, right? Stephen Hawking, yeah.
I keep seeing those advertisements in Wired magazine about AI and
Mm-hmm.
giving them
Oh, one happened just today. One happened just yesterday. Anybody hear about it? Google created a program, artificial intelligence, that beat the game called Go, that's an ancient Chinese game, 10 years ahead of schedule. Wow, right? And Google's created the driverless car. Now, it's ugly. I'm just going to tell you. If you haven't seen the autonomous, now there's a difference between the system that's built in that takes charge and the car that you can't drive. Have you seen the little, it's horrible looking. Right? If you're into cars, you'd never get one. But still, imagine cars driving themselves. It's a reality that's already happened, right? So again, and we're just here. So this chart, and this is what I want on your notes, is built on something called Moore's Law. So Moore's Law said that technology doubles every 12 to 18 months. And this is based on an observation, a guy named Gordon Moore who started a little company you might have heard called Intel. Have you heard of Intel? Intel Inside, okay. He made an observation way back in the day as he was watching technology and computing power increase. He's like, he made an observation that's now called the law because year after year after year, it is proven to be true. Now, we're going to talk about the impacts also on the computing side, but really, you know, computer and understanding how to do it. So let's go here. What is a computer? I mean, you all use them, but let's actually look at the definition that which I love Wikipedia. Why your instructors won't let you use it, we won't talk about, but I don't agree. Okay? Because it's at least looked at, but side topic. So when we talk about the definition of a computer, it's an electronic device. So electronic means it's run on what? Electricity. Electricity has how many states? 2, on and off. Okay? So what we're about to explain to you is the way a computer works. And it's going to be much simpler than you ever thought. But computer is an electronic device. Electricity has how many states? 2, which means it has to have a different numbering system. And the numbering system it uses is called binary. Okay, our numbering system related at all to this? Because what numbering system do we use? A base 10 decimal system, right? And by the way, it is related. The reason we have it is because that's how many fingers we have. Okay? So a computer, at its fundamental level, only understands or only has 2 digits. 0 and 1. That's it. And what it does is it combines those zeros and ones to then reflect everything we use on the computer. Whoa. Serious? Serious. Everything. That email you had, that phone call you made, that, well, most phone calls these days are digital. Almost, I think except satellite may still have some analog, but 99.9% of everything you do on the internet has at its base zeros and ones. Everything you do on the computer, zeros and ones. Okay? So what's binary? Is a numbering system that is based on 2 digits, 0 and 1. Computers are electronic, and that's why, so what's the connection between electricity, and binary? Electricity has how many states? Binary has how many digits? 2, zeros and ones. So that's why we have to have binary to make computers work. And I suspect you all have seen images like this where it's all zeros and ones, right? And if you've ever wondered why, this is why. But somebody read this. Somebody read it to me. There are only 10 types of people in the world? Okay, which camp are you in? Are you in the I understand binary yet? Probably not. We just started talking about it, right? But how many of you are like 10 types? Sounds like there's only 2 types, those who do and those who don't. So what do you think 1 0 is in binary? Oh, tricky, right? Okay, so after this lecture, this lecture is going to introduce you to it. You're going to have a video that you will watch that will take it to the next level. But the goal is after this one and next lecture, you at least have a basic understanding of binary. And the reason is almost everything we talk about hereafter builds on this concept of on and off. Okay? Okay. So really it's about lights and messages. Really that's what it's about. Now we're gonna change the term lights and messages, but we're gonna start simple and we're gonna build up. And by the way, what we call this in a computer is layers of abstraction. It's very simple at its basic level, but then we move up the chain and we start understanding it, because what you interface with is not these lights and messages. But everything you've done is built upon that. It's very simple to layers of abstraction that you deal with, okay? So let's say this, a light is on or off. Is there a message, and is there a traditional holiday we use a light to send a message? What is it? Halloween. If the light is on, what's the message we're sending? We got candy. The message is off, do not come to my house. Right? Isn't that the clear message that we're doing for Halloween? So if we have one message or one light switch, we can send 2 messages, right? So if we have 2 switches, we can send 4 messages. So we'll keep the come and go away message. We'll call that off, both on. But what are the other 2 messages? And what would they be? If we had 2 lights, one could be on, one could be off. One could be, and switch it, right? So what might be the other 2 messages? Say it again? Yeah, good. So that's the combination. So if we were like, you had a friend and you had 2 porch lights and you're like, one's on and one's off, it might be come over and bring beer, right? And if it was the other way, come over or don't come over, but send me a text, right? Something like that. But the idea here is we can build on this, right? So let's say we go up to 8 switches on our porch. 132 messages. Holy Mac. So, by the way, we really actually take this all the way to 32. So these lights and messages, and this is the example, okay? And actually on the next slide, I was actually going to do this with you guys. So let's actually walk this through. So let's say we had 2 lights. So we would have on, right? On, off, on, and off, right? So these are the what? Lights. Now, by the way, we're about to tell you another term. It's called bits. But for now, we'll call it lights. So if we're on, we say, come over. If we have one on and one off, what was my funny here? Come over, bring beer. Or whatever. A little big there. So let's take it a little smaller, right? So you guys make up one for the last one. What might be for the, right here. So what might be for the other configuration of M switched? Say it again. My wife's home. How about this one would be don't come. Well, actually, kind of the other one is don't come, right? So going back to this, right? So really we express this called 2 to the nth. So in your notes, 2 to the nth. So really, if we were to really express this the way computers, when we get closer to the meaning here, it wouldn't be on, it would be like this. On would be, what do you think? 1. Yeah, 1. And then this would be 1, and this would be 0. Okay, now we are making up the messages here, right? So in computers, standardization is a big deal. So these, and we'll call them a new name. We're about to switch, and it's going to be called bits and encoding. Okay? That will be the next thing you see me do. So now this one, and we'll just complete it just so you see it, right? And then this one would be what? Yeah, 0, 0, right? I think that's right, isn't it? Off and on? I always have to remember, okay? So we could go through and do the next round, but just keep that in mind, right? We can go all the way up to this. Now, in computers, right, and I think that's my next slide. Oh, no, actually, this is my next slide, and it's really kind of fun. Most people don't realize this. We went through this. We talked about this. I showed you this. How many have seen this? Do you know what this means? 1 and 0. It's power, but it's 1 and 0. Never see it the same, ever again. Okay? It's 1 and 0. That's where that came from. So I want you to get this idea from here on out, whenever you're doing anything with the computer, that everything you're doing comes down to zeros and ones. It is always interpreting from its understanding of zeros and ones to ours. The computer has to understand what we mean by understanding it in the way it understands it. Okay? So power button, zeros and ones. So really, this is called bits. Bits is a binary digit. Okay, so how many binary digits do we have? 2, zeros and ones. But when we talk about messages, really we talk about encoding. And so here's some examples of names that we have that are common in coding. ASCII is the old version of character encoding. So when we wanted to make, matter of fact, let me just show you, because you're going to end up doing something like this. So here's a website where it takes text, like if I put Rio, and I put, and by the way, you're going to do an example of this in your classwork. So I'm going to put spaces between each binary representation, and I hit, what's this word? Encode. Did you just hear me say encoding, right? So if I wanted to express Rio, that first series of 0, 1, 0, 1, 0, 0, 1, 0 is an R, a capital R. Lowercase r would be different number, different binary sequence. Okay? So, but you can see we have 3 characters, right? Because it's separated by the space. And by the way, the reason I want you to use the space, because it's really hard if you don't, then it's hard to tell which character is what. Then it's just a series of zeros and ones. Once it does, there it goes. You see the difference? So in your notes, you're going to do an example. Make sure you use spaces, okay? So what we're talking about here is characters, but everything, again, on the computer. So when we talk about images, here are common ones: JPEG, PNG, and GIF. And so what this is for every pixel, then there's a sequence of a number of zeros and ones to represent each of those pixels in color mass. And the video you're going to watch that helps take this concept to a new level will help you understand that. And I suspect, how many of you know what an MP3 is? Boy, it'd be fun. We're going to have a conversation about the MP3 and how it became what it is. AAC and other audio formats. MP4, video, MOV, video. So these are all just encodings of those zeros and ones to say when you see this series of zeros and ones, it means this. Okay, so we're switching from lights and messages to what? Bits and encoding. So make sure you put that in your notes, okay? So by the way, we have a little bit of a problem. So here's the challenge. Right now, and we really don't, the bits and the way we represent them in the computer is in silicone typically. Well, this silicone is hitting a wall. And the wall is that we've made it so small, it can no longer contain that state of on and off. And we have, so this is the classical bit, the on or off. And the problem is the material, we're reaching the limit of what it can do. And if we want to continue Moore's law, which you and I could debate whether that's a good thing or not, and I think in general it's just going to happen whether we want it to or not, we have to find a new way to make computers do what we want them to do. And one of the ways is called a qubit. So instead of on and off, we have on, off, and somewhere in between. But really, here's what I want you to know. This is at a molecular level. So if you've heard the term quantum computers, this is what is going to make them run. Right now, we use silicone and circuits, but we're going to probably, and again, there's different theories what's going to happen here, go to something smaller and faster. Because what was this built on? Anybody? Let's see who remembers the term. What's that? What's this chart built on? Everybody's looking at their notes. Moore's law. Moore's law said computers do what? Double every 12 to 18 months. So in order for us to continue getting up into the higher realms here, we're going to have to get across the wall that we're getting ready and already have hit in some ways, which, by the way, computers now in the processor, we'll talk about processors next week, have how many brains? 1 brain? 2? 5? 7? In 1 chip. And we'll talk about why, because again, we're doubling 12 to 18 months. Okay. So here's what you're going to do in addition to my introduction to binary. You're going to watch, well, let me just actually find it so we can talk about it. So I am going to put, as a matter of fact, I did it after the lecture yesterday, so I'll show you what it is. You're going to do it on your own. I'll go ahead, very nice. So it is in week, oh, sorry, it took me a minute here to realize where I was at. It is in week, what lecture is this? Week 4? Okay, so in week 4, I went ahead and did the write-up here. You have 2 additional things you have to do. I've already given you one. What was that? Besides the notes, what do you have to do? Security audit. Your Google Drive security audit. So here's what you're going to do. You're going to take this series of zeros and ones. You will copy it into this website. I'm not going to do it for you, although I did that. I'm not going to, and you would decode it. You'd figure out what I'm asking. Okay? Ooh. Awesome, right? Whoa. So the question I have is here, and then once you figure out your answer, and by the way, it didn't have to be long, right? Your answer, more than that, making sure you do what? Spaces. I do spaces, else it'll just be long line, and it'll be harder to understand. And even this is hard to understand. Then, when you do your answer, you encode it, okay? And when you do, and by the way, the reason I'm doing this is to help bring this concept real to you. This is how the computer does what it does in a very fast way. So when you get your answer, you copy and paste that, create a heading in your classwork, and this would be a heading 1. And what would be the heading we would use here? Yeah, binary answer. Okay? So that's one thing you need to do on your own just to have a little fun with this. The next thing is I spend a little time looking at YouTube because there's about 6 videos that I really like that talk about binary, but I ended up choosing one I hadn't chosen before. And this guy did a really fairly good job. His camera's a little out of focus and it bugged me, but for the most part I liked what he said. And he takes the concepts I've introduced to you today and it takes it to the next level. Because this stuff on binary is so hard for us to get because most of us don't understand it. And again, we're used to this kind of system, right? 10, 0 through 9 digits. This is binary. Uh-oh, sorry, people. Gotta, by the way, notifications, right? Gotta get rid of those, or at least mute them while I'm lecturing. So you will watch this. The heading, what do you think the heading on this will be? The title of the video, which will be How Computers Work. Information, Part 1. Okay, so that's the work you have for week 4. You'll have to watch this video. So next week, and come back here, next week I will talk about, we'll go drill down a little more on binary, and then we'll talk about the 3 big components of a computer. Anybody know what they are before we talk about them? Most important components. CPU, RAM, hard drive. The motherboard is just what houses all those things. Okay? So it's really those 3 devices and understanding them and how they work with this binary thing. And we'll talk about generations of computers. Okay. Show them. Say bye-bye. And we'll drop the recording. Thank you very much.